Okay, the next section we're going to work on is Chapter 1.5, Solving Inequalities. This should be a fairly simple section compared to 1.4 because most of you already know how to solve equations. If you know how to solve an equation, you should know how to solve an inequality. An inequality is just a symbol other than the equal sign. So if you remember, you've probably seen these before. We have not equal to, greater than, let me get my marker. We have not equal to, greater than, less than or equal to, and greater than or equal to. So those are all the symbols that mean not equal. It's just a symbol other than the equal sign. So let's go through and let's figure out how to solve inequalities. Basically, there are a few rules because we do have to graph inequalities, okay? A few rules that you need to know. If there's a closed dot, the numbers are solutions to the problem. So if you think about the inequality symbol, greater than or equal to, less than or equal to, those would have closed dots when you're graphing. An open dot, when graphing, the number is not a solution to the problem. We have symbols like less than and greater than, or not equal to. Now, one thing you have to remember, whenever you multiply or divide a negative number, you must flip the inequality sign in order to make the statement true. And I'll show you what that means. But that is a very common mistake when students solve inequalities, is they forget this rule right here while they're solving. So I'll show you an example of that in a little bit. All right, so we want to go ahead and solve an inequality exactly like you would solve an equation, except now you just have a less than symbol instead of an equal sign. So if I were to solve this, I'm going to subtract by 4 from each side to get rid of your addition and subtraction. So I'm left with negative 2x is less than 4. And then I'm going to divide both sides by negative 2. Now here's where my rule comes in. Okay? If you remember back here, whenever you multiply or divide by a negative number, you have to flip the inequality symbol. And what that means is I'm just going to take this symbol right here, and I'm going to flip it, and I'm going to make it greater than. So I have, this cancels, x is greater than, 4 divided by negative 2 is negative 2, and that's what it looks like. Now when you graph these, here's what I'm looking for on a graph. I want a straight line, and then you only have to actually put the number that you need. So in this case, negative 2. So I have negative 2 on my number line. And then I have an open dot on negative 2 because I have a greater than symbol. If you remember back here, we have an open dot when we have a greater than symbol. So that's why I have an open dot on negative 2. And then if you look, this symbol will serve as an arrow as long as your x is on the left-hand side. So this arrow is pointing this way, so that means we're going to go ahead and we're going to shade this way. And if you think about it, x is greater than negative 2. If this is a number line, all the numbers over here, negative 1, 0, 1, 2, 3, 4, all of those numbers are greater than negative 2. All right, let's solve another one. Exactly like we would an equation, we're going to go ahead and combine like terms. So this side is fine. So I have negative 1 is less than or equal to 2n, and then these two go ahead and combine. 4 minus 5 is negative 1. Solving the inequality, I'm going to get rid of my addition and subtraction first. Remember, I want to get n by itself. I have to get n by itself, so that means I'm going to add 1 to both sides first. Negative 1 plus 1 is 0, and this 0 we can take away. We still have 2n here. And now, how do I get rid of the 2? I have n is the variable I want to solve for, so I have to get rid of the 2, so I'm going to divide both sides by 2. 0 divided by 2 is 0. 2 and 2 cancel, and I'm left with 0 is less than or equal to n. Now, one thing you have to recognize here is my variable is on the right side. So before you graph, switch it around and read it this way and then rewrite it. So I have n is greater than or equal to 0. I always want my variable on the left-hand side. Since that's the case, I'm going to go ahead and graph. My number is 0. Do I have a closed dot or open dot? Closed because of the equal to symbol below it. So I have a closed dot on 0, and then my arrow is still going to the right. So it looks like that. All right, next one. Just like I would solve an equation, I'm going to combine like terms first. So 2p minus 4p gives me negative 2p is less than or equal to negative 2. And now I'm going to divide both sides by negative 2. And be careful, as soon as you see this, you should be thinking, okay, I'm dividing an inequality by a negative number. So I have to flip the sign. So I'm going to have greater than or equal to. So I have p is greater than or equal to 1. I don't have to rewrite this one because my variable p is already on the left-hand side. So when I graph, my arrow is going in the right direction. So I have a 1 here. I have a closed dot because of the equal to symbol, and my arrow is going to the right, which is right. So there's your graph. Now they're going to get a little more complicated. Just like I would solve a normal equation, this is an inequality, so I'm going to distribute my negative 4. Negative 4 times negative 6 is positive 24. Negative 4 times positive 3a is negative 12a. I'm going to combine my a, so I'm going to add 12a to both sides. So I have a plus 12a is 13a. Minus 15 is greater than 24. Add 15 to both sides. So I have 13a is greater than 39. Divide by 13. And since that's a positive number, I don't flip the sign. So I have a is greater than 3. When we graph this, variable's already on the left-hand side, so we're good to go. I'll use a different color this time. So I have 3, and I have an open dot because there's no equal to underneath the inequality symbol. My arrow is going to the right. All right, let's solve another one. I'm going to go ahead and distribute this one as well. So I have 26 plus m is greater than or equal to 5 times negative 6 is negative 30. 5 times 3m is 15m. Combine like terms, I have m's on both sides, so I'm going to subtract m from both sides. So I have 26 is greater than or equal to negative 30 plus 14m, 15 minus 1. And now I'm going to add 30 to both sides. Which gives me 56 is greater than or equal to 14m. Divide by 14. Would be 3, I think. Greater than or equal to m. Now, be careful here. Don't graph it the way it is. Notice how my variable is on the right-hand side here. I have to move it to the left-hand side in order to be able to graph it and use the arrow. So rewrite it, reading it from right to left. So I have m is less than or equal to 3. And now go ahead and graph. So let's draw my graph. And I have 3. It's a closed dot because we have an equal to. And this time my arrow is going to the left, so I'm going to make my graph to the left, which makes sense. All of the values less than 3, or less than or equal to 3, are on this side, including 3, so we close the dot. All right, let's try another one. Go ahead and distribute. So I have 6x plus 3 is less than or equal to 6x plus 12. So I'm going to subtract 6x from both sides. They cancel on both sides, and what I'm left with is 3 is less than or equal to 12. Well, let me ask you this. When is 3 less than or equal to 12? The number 3, when is it less than or equal to 12? It's always less than or equal to 12. So no matter what number I put in here for x, this is going to be always true. So we would say all possible solutions, all real numbers, depends what you're doing, Math, Excel, or a worksheet, always true. Those are all correct answers. Now, what does this graph look like? X is not equal to 2. Well, if I have a graph, a number line, and 2 is here, how could I show when it's not equal to 2? It's everything except for 2. Well, if you remember back from one of the first pages, when we talked about closed dot, open dot, whenever we use a not equal to symbol, we have an open dot. So let's go back and let's look at my problem. Not equal to 2, that means I have to have an open dot, but everything over here and everything over here are not equal to 2. And that's what your graph looks like. It's everything to the right, everything to the left, except for 2. That's why we have an open dot on 2. All right, let's solve another one. Okay, just like an equation, I'm going to get rid of addition and subtraction first. So I'm going to add 5 to both sides. Negative 12 plus 5 is negative 7, is greater than r over 8. Now, how do you get rid of division? What's the opposite of division? Multiplication. So I'm going to multiply both sides by 8. So I have negative 56 is greater than r. Change the order so that your variable is on the left-hand side. So r is less than negative 56. And then graph. Find your number, negative 56. I have an open dot. Since it's less than, there's no equal to symbol there. So open dot, arrow here is going to the left. And there it is. All right, let's try this one. So I'm going to divide both sides by 4 here. I have x is greater than negative 12. And since we divided by 4 and not negative 4, we do not switch the symbol. A lot of times people think if you get a negative answer, you have to switch the symbol. No, only if you multiply and divide both sides by a negative number. Then you switch the symbol. So when I graph this, here's my negative 12, and I have an open dot. Arrow's going this way. There's your graph. All right, let's try this one. Subtract 2a from both sides. So I have negative 4 is greater than 3. Is that a true statement? Is negative 4 actually greater than 3? Well, if we were to draw a number line, negative 4 would be here, 0 would be here, 3 would be here. Is negative 4 greater than 3? No. So this is no solution or no possible solution. If you remember on Math Excel, they gave a symbol that looked like that. That just means it's an empty set. There's nothing there. Sometimes it looks like this. All these mean the same exact thing. Okay. Finally, the last thing we're going to talk about is how to translate words, which we already did this before. So now we're going to talk about how to translate this into an inequality instead of an equation or an expression. So I have negative 3, so write down your negative 3, times, means multiply, a number. When we have something that looks like this, a number, just create a variable. Okay, negative 3 times x is at least 9. So that means it's bigger than 9. And it also could be equal to. If it's equal to 9, it's at least 9. So we would say it's greater than or equal to. So now to solve, I have to divide by negative 3. Flip your sign, since we divided by a negative, and we get negative 3. Go ahead and graph it. Here's my negative 3, closed dot, arrow going this way. A number decreased by 6 is greater than negative 5. Well, remember I said when you see the word a number, we just know that stands for a variable. Decreased means minus, so minus 6 is greater than negative 5. So we're going to add 6 here. So x is greater than 1. Graph it. Open dot, arrow to the right. And that's it. Go ahead and try worksheet 1. Remember, worksheet 1, you are actually going to have to go get the worksheet on Math Excel, print it off, write it on a separate sheet of paper, or I also have empty ones, blank ones printed in my room if you want to stop by when you're here and pick up an extra one.